We can't go long hours anymore.
All right. Well, here we are. We're at week number 5 of our tech class, 5 of 10. So we're getting to the halfway point. And tonight, we're going to talk about amateur radio equipment. And the things that we're going to cover, we're going to start out with modulation and how information combines with RF. You know, it's we got all these RF signals out there. Well, how do we get our voice on them? Or how do we get a digital signal on these radio waves? We're going to talk about that. We're going to talk about some basic operation of transmitters, receivers, and amplifiers. We'll get a little bit, not too deeply, into some of the digital mode characteristics. And then we're going to talk some about power supplies and batteries. And, you know, how do we make that radio run, right? That's an important thing. If you got to make it run the right way, or you can what we call smoke it. And we don't want to do that. All right. So let's start with modulation. You know, in our previous classes, we talked about the ham bands, right? And somewhere here, I stopped at a national park the other day and tried to activate it. I got 5 contacts, and that was it. I needed 10 to activate that park. I was on 20 meter, but I was in a hole. So I had mountains and hills surrounding me. So my signal was probably going, boing. Yeah. You know, it wasn't getting where I wanted it to. Okay? We talked about that, right? How the propagation goes. And so I made some contacts. I got some from Wisconsin. Lee was hearing some of the folks coming back at me, but Lee couldn't hear me. And I got some from California and another one from Idaho. But so I got a few, but then it wasn't good. I found some other places that would be great. So next time I go out that way, I'm going to stop up on the top of the hill where the buffalo roam. And there was lots of those out there.
Stay away from them.
But stay away from it, exactly. Okay, so anyway, band. We talked about the bands. And, you know, as we talked, a signal can have both frequency and strength or amplitude. And that becomes important when we talk about modulation. So, modulation is what enables us to communicate information using radio signals. It's adding information to a signal in some way. As we add that information to that signal, that's called modulation. A signal that does not carry any information, that's an unmodulated signal. It makes sense, right? No modulation, unmodulated. And on the other end, when a receiver, gets that information on that radio wave, and it takes that information and it converts it, it's called demodulation. So it's demodulating the stuff that you put into it, right? So that you can hear it. Okay. So as we talk about modulation, if speech is the information that we use to modulate a signal, the result is what we call phone or voice mode. It's a phone or a voice mode signal. You know, we think of phone as you talk on the phone, right? Well, voice. That's kind of how we think about this, is the voice side. Now, if we take data characters and modulate a signal, the result is a data mode or a digital mode. Analog modes carry information that can be understood directly by a human, just such as speech. Or another example is Morse code. And we're going to get a little bit into Morse code in just a little bit. And we've got our professional CWer here to give us a demonstration tonight. And that digital or data modes carry information as individual characters. And they are read or displayed by a computer. Okay, so these are kind of the different modes. You got phone, right? You got CW, you got digital. These are the different ways that we can communicate, and we can put this information onto a radio wave and send it off into the ionosphere. And hopefully it'll come back down and talk to somebody. Okay, sometimes.
Unless you're in Teddy Roosevelt.
Unless you're Teddy Roosevelt sitting in a valley. Okay. So, signal characteristics that can be modulated. So as we talked about our signals and our waves a few weeks ago, we had one of these up here, right? Who remembers what this is? It's a sine wave, but the height is amplitude. You're absolutely right. Okay, who remembers what this is?
Where you work on frequency.
Frequency, exactly. Amplitude. Okay, amplitude's going that way, frequency is going this way, right? Well, both of those things can be impacted in order to modulate a signal and put information on it. So we play with the amplitude or we play with the frequency. Now these are going to come into play. Just remember this word and this one as we get a little bit farther, and it'll make a lot of sense. At least I hope so. Okay. Where am I at? Here we go. I thought we were getting close. Okay. Okay. So the simplest radio signal with the strength and frequency that never change is called a continuous wave. The strength, the amplitude doesn't change. Frequency is there. Okay? So the strength and frequency that never change is called a continuous wave. Continuous wave. Abbreviated CW. You hear CW a lot in the ham world. The simplest type of modulation is a continuous wave turned on and off in a coded pattern, such as Morse code. Okay? So you have this wave. It's continuous. It's going on. All of a sudden, you turn it on. You turn it off. You turn it on. You turn it off. And you're able to send a signal that way. So Morse code radio signals are called CW just for that reason. You're turning the signal on and you're turning it off. Now Randy is a professional CW operator.
You use the term loosely.
I use the term he is. He is great. So I've asked Randy to share with us the alphabet in CW, or Morse code, or what we call CW. And Randy is using an electronic keyer, which right now it's not hooked up to a radio, but we'll be able to hear what it sounds like. And when he's operating, he'll hook this up to a radio and send the signal out, and he listens for those signals back. Now I've listened to him do this, and I'm going, wow. It's not, we had 8 weeks of CW to teach. Randy taught the class. He's a very good teacher. I'm just a very slow learner. I've got SOS down.
CW is like learning a foreign language. Once you get what it sounds like, then it's not so bad.
Yeah. Go stand by him.
I will go stand by Randy, yes. And so at this point, I turn some time over to Randy in our class to demonstrate some CW and share what other knowledgeable insights you would like to do.
All CW characters are made up of 2 parts, a dit and a dot, right? This is a dit. and this is a DA, a single. A DIT, this is just a short, and a DA is 3 times longer. So a combination of DITs and DAs give you the different letters of the alphabet. For example, of the letter A consists of 1 DIT and 1 DA. 1 DIT, 1 dash. That's A. Now you hear the difference? Now if I hit 2 DITs, so you get to the point where you can start to hear the difference. And as you listen to it more and more often, it becomes normal, like normal speech, talking back and forth. But I'll send you a little sentence here, and I'm running at about 20, 25 words a minute, which is fairly quick. Back in the day, when you used to get your hand license, you had to learn 5 words a minute to get your novice license. Novice is no more. Now it's a technician. There's no code requirement. You went from novice, technician, general, you had to get 13 words a minute. You go from general to advanced, and up to extra class at 20 words a minute. And you had to get code to get your license. For a lot of good reasons, the FCC decided to do away with CW. Now, there's a lot of people that swear by CW, and there are some of us that swear at CW. But it's a lot of fun, and it is a way to communicate very easily. CW characters are very easily understood over the airwaves. Where a voice, a sideband contact, is a little noisy, a little bit of hash with it, CW is usually pretty clear.
You have 2 different keys for each, for dash, or?
Now this is called an iambic keyer. It's an electronic keyer. As long as you hold the paddle, it sends out a bunch of dits. Hold the other side, gives you the dashes. So how you move your fingers gives you the combination dits and das.
There are different kinds of keyers. This is iambic. They're also what they call a straight key.
Straight key, or like an old telegraph key if you've seen those. There's another one called a bug, which is a semi-automatic. The dits are automatic, but you have to get the dots like that. That's called a bug. And there's a cootie is another one, where it has a single blade, and as you move it back and forth, however you move your fingers, will give you the dots. So usually we learn on a straight key because that's probably the easiest. But anyway, here's a little sentence for you. Good evening, class. Oh, you all copied that, right? Jeff did, I know.
It's because I'm reading over his shoulder.
Here is this is the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, T, S, T, U, V, W, X, Y, Z.
So if you make a mistake when you're sending a message, is there like something that you do to say, forget that? So that's like clear?
That's with the, oh yeah. But I gotta tell you, most people sending code make mistakes. And you don't listen for individual characters. For example, the word the, one of the most common words in the English language, right? Now, people are going to hear that as the, even though I sent T-S-E.
Oh.
But in a sentence, the. So, but if I was going to send a call to Jeff, right? Jeff's call is N0JFY. So I would send his call, my call is WJ0L. So it would sound like this. I just sent N0JFY. This is WJ0L. And Jeff would call back and say, go ahead.
Go ahead.
Go ahead.
Yeah.
So anyway, that's the real quick and dirty with CW. And I got to tell you, I learned this, well, I got my license early 80s, somewhere in there. I learned Morse code and I let it go for about 15 years. Never operated. And half a dozen years ago I decided to pick it up. And you know the old saying, it's like riding a bike. Once you learn it, it really is. So. But it's a lot of fun. It really and truly is a lot of fun. Jeff talks about Parks on the Air, the POTA. Using voice on a radio like that works really well. And he runs 100 watts. I could run 5 watts with CW and have the same success. It is that much clearer than a voice contact. So.
Yeah, we'll talk about that in a little bit later in our class tonight, how the different modes operate differently within a busy, noisy environment. If you have a busy, noisy environment, if you know CW, that's a great way to get through that.
Yeah.
All right.
What else need? Is that good?
That's good. Thank you, Randy.
The Morse code signal that a repeater sends out when you connect to it, is that an automatic thing that's
Yes.
set up in the,
Yeah.
that's not somebody actually doing something?
No, every
right?
10 minutes it has to identify itself. So it just sends out automatic. The 015, instead of using Morse code, uses the kids. But most of them use a Morse code signal. So ours would send out W0SB.
And that has to send it out how often, every 10 minutes?
I think it's 10 minutes on repeat. So it always has to identify. When you're doing a voice communication, we're talking back and forth, you're supposed to identify yourself at the beginning, every 10 minutes, at the end.
At least every 10 minutes,
That's right.
nothing more.
Every now and then we go a little longer, and then sometimes
Yep.
But in the test,
you're right.
Good, good. Yes, I was up at Camp Ripley when we were talking. We put a young man on the radio, right? I'm the control operator. It's my responsibility. It's my call sign that's out there. And he was talking back and forth to Lee. And they were having a great conversation. And it was, I don't know how long we went. It might have been 15 minutes.
The dinosaur?
Dinosaurs.
The dinosaur conversation. And one of the guys behind me, one of the troop leaders, he comes up and says, aren't you supposed to identify? You're absolutely right. So I grabbed the radio and identified my call sign to Lee, and Lee identified his call sign. And we got ourselves back legal. But you are supposed to do that, and occasionally you'll forget, especially if you're in a long conversation, but that's something to definitely remember.
Just not totally related, but how do you make up a call sign? And what's the number of characters you use?
Yeah, so initially when you get your first license, your call sign will be assigned by the FCC. And it will be 2 letters, the number 0. It's based on your geographic location, and we're in region 0, okay? So, and then you got 3 characters at the end, 10. 10, but they use 0, okay? We're in region 10, but they use 0. And so my original call sign was KF0CWC, Kilo Foxtrot 0 Charlie Whiskey Charlie. And that's a mouthful. And
You guys use phonetic alphabet for that?
most of the time,
Letters? Yeah.
most of the time, yeah. Yep, using the phonetic alphabet. And so, I went from that call sign, and you can get what they call a vanity, just like a vanity license plate. You can get a vanity call sign. And so I was scratching my head, what vanity call sign should I get? And as you get higher with your licenses, you can get one when you're a tech, but you're limited to what you can select from. As you get to be a general, it opens up a little bit more. And then as you become an extra, it opens it up even more to what you can select as far as your call sign. And so I was thinking, I was scratching my head. And so I was thinking, okay, we can start with A, we can start with N, we can start with W, we can start with K. Those are the letters for the US, okay, your first letter. And so I'm thinking, okay, which one do I want to use? And I started playing around with it, and I said, okay, I want maybe just one letter at the beginning. And so I selected N. And I thought, okay, I know what the next one is. It's going to be a 0. But what do I want the last one to be? Well, something maybe close to my name. And so I go, okay, J, okay. Well, N0J, that was already taken, so I had to stop there. N0JF, that was already taken. I couldn't have that one. So I threw in another letter of my name. Why? And then I read it. It is No Jeffy. And I remember my grandfather always calling me Jeffy. He called me Jeffy Dick. And I'm going, no Jeffy. Okay, there we go. So that's how that call sign came to be. But then what you do is you apply for a vanity call sign. And you can put selections in there. And it takes 18 days for them to review it. And then you can get your vanity call sign. So that help answer that question?
Oh, yeah.
Okay.
I always wondered about that from the beginning.
Okay, but your initial one, the FCC will assign that.
Question, do you think the original one that you're given will be reassigned to someone else?
Eventually, yeah.
Just like a phone number?
Yep. After 2 years.
Oh,
They don't do anything for 2 years.
oh, okay.
And then they will reassign it. If somebody asks for it. I mean, they just keep going up the alphabet as they assign new call signs. But somebody could request it. I don't know why they would, but somebody could. All right. Let's see. Okay. So, this is right out of the book. Information can be added to an RF signal by modulating the signal's amplitude and turning the signal on and off, as in Morse code, as we demonstrated. That's a very simple form of amplitude modulation. And a tone or speech can also be used to modulate a signal, resulting in a signal whose shape or envelope contains information from the tone or speech. And I have my pointer somewhere, but I don't know where. Right here. Okay. So as we look here, this is a CW, right? Turning it on and off. Dot, dash, right? Well, if we modulate with a tone, we put a tone in here. Here's an unmodulated RF signal. Looks all the same, right? Nothing happening. Just boring as can be. We turn it on and off. We get a little bit of more excitement here. Then we add an audio tone, and we see that we go up and down. Why do you think that would be? Any thoughts? Why would it go up and down?
The sound of your voice.
There you go. There you go. So you're dealing with the power and the amplitude of that signal. And that is that modulation that you're sending your voice. You're changing this unmodulated RF signal to look something like this based upon, what your voice is. That's your radio doing that for you, right? But it's based upon that modulation that puts it into that other form so that other radios can come back and say, oh, that's N0JFY, okay? So it's basically you're varying the power or amplitude, and when you vary the power or the amplitude through amplitude modulation, that is also known as AM. You ever heard of AM? AM radio, right? Now, so varying the power or amplitude of a signal to add speech or data information is called amplitude modulation, or AM. Morse code is the simplest form. An AM transmitter adds your voice to the unmodulated signal by varying its amplitude. Okay, an actual AM signal is made up of 3 separate signals working together. You have a carrier, and you have 2 sidebands. So you have a carrier signal and you have two sidebands. I've got a graphic that will show this in a minute. The carrier signal is a steady, unmodulated signal, just like the one up here on the top, okay? An unmodulated signal. The upper sideband, known as USB,
Okay.
is a signal is higher in frequency than the carrier by the frequency of the tone. And the lower sideband, known as LSB, or abbreviated that way, is lower than the frequency of the carrier. So, here's your carrier frequency right there in the middle, 800 megahertz, or kilohertz. And you got two sidebands. You got a lower sideband, and you got an upper sideband. Okay? And each of the sideband contains all of the voice signal information. That's where the voice signal is. It's in these sidebands. It's not in the carrier. That's just out there to carry the signal, but it's in the sidebands. This can get confusing and it can make your head spin. So don't worry about that. It's made my head spin. My head's probably still spinning. And a lot of times we'll hear of, we're going to talk on frequency 10.805. No, 28. Yeah, see, it's been a long day. We're going to go to 10 meters, 28.405. And that's where we're going to talk. And we're going to talk upper sideband. And if you ever hear Jay talking about his net, which as you get your licenses and you get on listening to the repeater, he'll talk about his net, his mosquito net, Wednesday night at 9 o'clock. Upper sideband on 10 meters, 28.405. Come join us. And technicians can't get on. You can get on that one because that's part of your band that you have the authority on, okay? But he will always say it's on the upper sideband. So we're on the upper sideband. And what happens is you concentrate that signal down on the upper sideband, you get more power there. And as you remove or suppress the carrier in one sideband of the AM signal, it creates a single sideband. And all of the signal's power is then concentrated into one sideband. And the single sideband signals are effective for long distances and weak signal voice contacts. You might want to remember that piece because that one's going to be on the test maybe. Just a hint. Talking about weak signal voice contacts, single sideband. That's where you want to be. That's where you want to go. Okay. Any questions about that? I was kind of talking about AM signals. Now there's a couple of other ways that we can modulate the signals. As we talked about amplitude, and that's what we covered with AM, right? There's frequency. We're going to talk about that now. And then there's also phase. We talked a little bit about phase last time, or a couple of times ago, where it's kind of shifted a little bit, and it's in and out of phase. You can use phase to modulate as well. But modes that vary the frequency of a signal to add speech or data information are called frequency modulations, or FM. I was listening to a lot of FM on the way home from Idaho, but not on the ham bands. I was listening to the radio station. But guess what? They use frequency modulation to get that out there. Okay? And I might be getting ahead of myself because I think I have a slide on this later, but do any of you remember the days when AM radio was really the thing? And you really didn't hear much about FM radio?
KGWB, channel 63.
Okay. And you'd get a lot of static, right?
Yeah,
What did it sound like when they started doing FM?
it's pretty clear.
It was pretty clear, wasn't it? FM has a tendency over AM to be much clearer.
That's when you got to the age where you listen to KQ.
Okay, there we go. Okay. So note that the frequency of an FM signal varies with the amplitude of the modulating signal. So the frequency can vary, okay, and you kind of, with FM, you play with the frequency in order to get the modulation done. And phase modulation, also known as PM, it's very similar to FM. And within this manual, once they get to this point and they say there's phase modulation, they say they're similar, we're only going to talk about FM, okay? And so just know that it's there, but it's another way to modulate your signal to get a signal out there. Okay, because of FM's excellent noise reduction or noise rejection qualities, it is the mode that is most used by VHF and UHF repeaters because of the clarity. Okay, that's what it's mostly that's where it's using that FM side. And it's also used for packet radio on VHF and UHF. Keep that in mind for the test question.
What's a packet radio?
Randy, you want to take that one?
Packet sends the information in a burst of, it almost sounds like noise, but it's all the information goes, and then you get another one. Have you heard of radio teletype, RTTY? It sounds like electronic typewriter as it goes across the air. But packet gives you a burst of information, electronic signal, just burst, and it's received on the other side and decoded. So you could hear it, but you wouldn't know what it says. It's got to be electronically decoded.
Packet of information.
Yep. All right. So, as we start here, on the left we've got an unmodulated signal, right? It's all the same over here. There's nothing different from any of those deals. Then we have our the wavelength of our modulating signal. And what it does is it changes that unmodulated signal to something a little bit different. Do you see the differences there between A and C? That's what the modulation does. It changes that unmodulated signal so that you get a modulated signal that has the information in it. Over here on C, you have the information embedded within that wave, that radio wave. Okay. So as we talked about single sideband a little bit ago, the power is concentrated into a narrow bandwidth, and this makes it possible to communicate over long distances and in poorer conditions than with AM or FM, and particularly on the VHF and UHF bands. Okay, as you use single sideband, you can get better communication out there because the signal is concentrated. Now, for even better range, and extremely narrow CW signals are the easiest for the human operator to send and receive, as long as you know CW. But especially in noisy or fading conditions. Now, I know Randy can make a lot of contacts on CW when the bands are just horrible conditions, but he can get through it because of the way the CW goes out, and it breaks through that noise. So hams often refer to CW and single sideband as weak signal modes, since they are more effective than FM at low signal strengths. Now, doesn't mean that they only work in weak signals, okay? Don't let that confuse you, but they do work in weak signals better than some of the others. Okay? Questions that Randy can answer? That's why he's the president of the club.
Yeah.
Okay, so I grabbed the table out of the book just to show the typical bandwidth of some of these different signal types. And there's a lot of different ways that we can get out there. You got AM broadcast. That's your radio stations that you hear on the AM dial, right? The FM broadcast, that's Pink Floyd and all those other guys that broadcast on that stuff. And then you got FM voice. That's what ham radio is operated as, single sideband voice, AM voice, CW. Those are all different modes that we can operate under. Okay, so now we're going to move on a little bit from some of the theory to some of the practicality of what's this radio stuff all about. So whether you use a transceiver, what's a transceiver?
Transmits and receives.
Transmits and receives, so they call it a transceiver. Yes. So you're most likely you're going to use a transceiver. This radio right here is a transceiver. Or you might use a separate receiver and a transmitter. I don't know many people that do that, but you could do that. There are two things in common for all of them. You can control the frequency, and you can control the mode. And so here's an example of a couple of radios. And within these radios, over on this one, which is a Kenwood, yep. It has some band buttons, so you choose which band you want to be on. That's where you're going to choose your band, like whether you're going to be on 20 meters, or you're going to be on 10 meters, you're going to be on 40 meters. You choose your band, and then you can choose your mode. What mode you're going to be in. Are you going to be in CW? Are you going to be in upper sideband? You're going to be in, I don't know, we'll look in a minute. But you can choose your mode that you want to be in. Now this other radio that's over here, it's the same radio as this one right here. Okay? And that's why I brought it. Because I saw that they had the picture of it, and I thought, okay, let's just bring the real thing in. Now, you'll notice I do not have this hooked up. And I have this not hooked up intentionally. Why do you think that would be?
So you don't accidentally transmit.
So I don't actually transmit, because if you look back here, I have no antennas hooked up to this thing. I do not want to transmit with this radio. I do not. So to avoid that, I don't even plug it in. Okay? But I can power it up, which I will do. And as you see, as it came up, it had no Jeffy on there. It has my call sign in it. But anyway, where do I have this set up? Okay. All right. So, it's kind of small. I don't know if you guys can see this. But, okay. So if I want, when I turn this radio on, I want to go and determine which band I want to be on. I will push this button here that says band. And it brings up a list of numbers. Okay? It has a 1.8, a 3.5, a 7.0. It's got a 14. What do you think those are?
Megahertz.
Yeah. So, but we're talking bands here. You know, we're talking, 20 meter. We're talking 40 meter. What was our formula? 300 divided by frequency, or is it frequency divided by 300? Anybody remember?
$300 divided by frequency equals meters.
Okay, 300 divided by frequency is meters, exactly. So if you take 300 divided by 14, I'm guessing you're going to come somewhere close to 20.
1.4285.
Okay, and that's in the 20 meter band. Okay, if we were to look at our chart, which I have up here somewhere, if we were to look at our chart, that would fall in the 20 meter band, right? So some radios, I'm not sure which ones, does the 7300 have the bands, or does it have the... So the 7300, you would have the 20 meter band that you would select. Well, on the Yaesu 991A, you actually are selecting the frequency which goes with that band. So each radio is a little bit different, so you just need to know what your radio does, okay? So if I wanted to select, like I wanted to select 14, I'd be on the 20 meter band, and I would be able to know that, okay, that's where I'm at, and my antenna, I'll need to make sure it's tuned to that. And so once I do that, then I go, okay, what mode do I want to go to? What do I want to play with? Well, so I click on the mode button, and as you can see here, I've got lower sideband LSB, upper sideband, I've got AM, I got CW, lower sideband, CW, upper sideband. I've got RTTY, and I've got data. And so there's a lot of different modes that you can select on your radio, okay? So those are some of the things you need to be aware of as you're playing with your radio. But it's good stuff, and there's lots of buttons on here, right? Lots of buttons. So once I've selected my band that I want to be on, I have to figure out what frequency I want to be. It'll take me to the band, and then I use this knob here to change the frequency. And I can dial in quickly. I might have this set up fast, I don't remember. I can set it to fast so I can scroll through most of the band all at once, or I can go slow and I can really dial it in to get just to a perfect match with the signal that I'm hearing. And so that's kind of some of the things you do as you play with these radios.
Now just give you the frequency within that band when you scroll.
Actually, you can scroll outside of that band if you're not. You just got to be.
You gotta watch your chart.
You got to watch your chart.
Most of the modern radios, when you get to the band, it'll give you a beep.
It'll beep and it'll tell you you're going across the band. Yeah, it does. And this radio does that. It's kind of fun to do just to hear the beep. But
Just don't transmit.
don't transmit it. You might.
The icons won't let you. Once you get out of the band, you can't.
Oh, is that really?
It won't let you. The new modern radios are pretty safe.
Fails.
Pretty,
Yeah.
the only way you get into trouble is when you get your technician license. You don't have privileges on some of the bands, so you can get in trouble with that.
Yeah. So you want to make sure that you have this chart, and you take a look at technicians, which is red, I believe. Yep. Is it? No, it has an E, A, whether you're an extra, amateur, general, or technician, and it tells you which ones you have privileges on.
So you're saying it won't let you transmit outside the ham bands?
The newer radios
Can
will.
you receive?
Yes,
Yeah, you can receive and listen.
you can receive it anywhere on these things. You just can't transmit.
That's smart.
Yeah, it really
Yeah,
is.
it is. And I don't know what radio the guy in Idaho was using that got him into trouble with the FCC, but cost him $37,000. So, yep, exactly. You don't want to be doing that even if you want to help. Don't transmit outside of your band privileges.
You don't hear a lot about the FCC enforcing, but every now and then. So you got to keep in the back of your mind, they're there. They're always there. If you step too far outside, they'll get you.
Yeah, and in that case, more than likely somebody reported him,
Yeah.
and then they were able to figure out where he was. And they had it. I mean, he gave his call sign, so they knew how to find him. So,
So, this chart.
yep.
Okay, list the different licenses. How does that apply to this chart?
Okay, so if you look here,
Oh, the
extra has all of these. So,
Oh, okay, and T for technician. Okay.
yep.
Okay.
And so where it has it broken down, where you got multiple lines, extra would have all of these. Advanced would have these. General would have these. Tech
To those
wouldn't have anything on that
20
one.
meter, right.
But if you go down to 10 meters, where's 10 meters? It's here. It's hiding
Yeah,
from me.
there.
Oh, it's up here. You can see that techs have privileges right in here.
Just a little bit.
Just that little bit.
Yeah.
But that's why we have that net at 28,405, because that's within the tech bandwidth.
That's why we're probably gonna teach a general class once we do it this one.
Yeah, we'll probably go, everybody get their tech, and then we can teach the general class, following. And add to that knowledge base, and get those privileges, extra privileges
And
out
if
there.
you don't pass the tech, can you take it again right away?
Yeah. So it depends on what you passed it by. You can take it the same day if you're within
I think he says 5. isn't it?
within 5 questions. And then you could actually take it again that same day. If not, then you can take it at the next time that.
So if you don't pass it, you take it again that same day, is it the same questions?
Nope.
No.
No.
It's from the same question pool.
Yep. It's from the same pool, but it's a different
There's
question.
100 and some out of in the pool, and
There's-
they do 30.
There's 35 questions on the test. The pool, I believe, is 400,
Yeah,
So-
that
that many?
is a lot.
something like
The
that.
difference is that it's the same question asked a little different,
Yeah.
so.
And as you're studying hamstudy.org, you'll see that the same question can be worded just a little bit differently.
Our colleague in the back, Lee, he took his extra test and he failed it. And he said, I'm done, I'm not taking it again. Well, we talked him into taking it again, he took it at the same time, right away, and he passed it. A little different test and he passed it, so.
And it's just a matter of, maybe there were some questions on the first one that you did not, comprehend, but the second one might be pulled the questions, hey, I knew these down pat. Right, Lee? Yep. Yep, there's 4 or 5 different
Yeah,
sets or something that they use.
you'll pass it. I have faith.
Okay, so here's our radios example. And, okay, what's going on here? Okay. Go figure. Your computer battery is running low on power. So it's stopping everything, of course. Where are we at? Okay. We'll give it some power. Now it should work.
You dropped something on the floor when you grabbed that out. It's right behind you there, that white thing on the floor. I don't know if that's anything, but.
Yep, it is. Thank you. Okay. So, as we were talking about the different bands, 7 relates to 40 meters. We were talking about the 14 relates to the 20 meters. So this is just kind of a chart that shows you which ones relate to what. Often you'll hear on nets, repeaters, it's on the 2 meter band, or it's on the 440, and well, that's a 70 centimeter band. So you'll hear them interchangeably used. So you'll get used to that as you go along. First little while I was going, huh? What are you talking about? But after a while, it just becomes kind of second nature as to where those frequency falls within the different bands. Okay, so let's talk about the transmitter. We talked a little bit about the receiver, how the, well, maybe we didn't, but we talked about the transceiver. But when it comes to talking on the radio, you'll hear the acronym PTT. What do you think that stands for? Push to talk. Yeah. So manual. I push it, I talk. Okay, push to talk. You can set your radio up with a Vox control, which is voice operated transmitter. It's an automatic. I've never used that personally.
It works fine as long as you don't have any background noise. If your wife says, hey, it'll send it.
Is there a little lag time though? I mean, it's not just.
It is a little bit, lag, yeah.
like talking to somebody on, when their phone is on. Oh, crap. Well, when you push the button and you don't have to hold the phone.
Oh, your speaker?
Yeah, speakerphone, there's always a lag. It's just irritating.
Yeah. And so there's another way to transmit is using a key, just like Randy was using when he was showing us the CW. Now, a thing to keep in mind is microphone gain. That's the amount of power that when you're talking, how much of that mic is going out. And on this radio, I don't know if I have it set up to show. So at the bottom, you'll see this, there's very little. It says mic gain, and it says 30. Okay? That's adjustable. You can adjust that mic gain. If you have that mic gain up too high, you're going to be, basically, you're going to be blowing people out. And what's the term? Coming in hot?
Splatter.
Splatter. And when I first got this radio, I didn't know a whole lot about it. And so I'm asking Randy one day, I said, how's my signal coming in? He says, you're kind of hot and splattering. Ah, how do I fix that? Turn your gain down. I turned the gain down. How am I coming in nowadays, Randy?
Perfect.
I don't know about that, but I'm coming in better. I'm coming in better. Okay, so as you're playing with your radios, you're not often going to know how you're actually sounding, right? There's nothing wrong. It says, how am I coming through? What am I sounding like? Guess what? The guys on the other end, they're going to be glad to help you. I mean, you'll find occasionally what I call an idiot out there. And they'll come back with some rude comment, but I find that that's very, very rare. Pay no attention to them, because 90% of the time you're not going to hear that anyway. The only time I've heard it is when they've been yelling at somebody else. So, but you just kind of ignore that. And there's a few of them out there that are bad apples, and you're going to run across them. But the majority of the ham operators that you're going to find out there, they're there to help you. They would love nothing more to help you. You say, hey, I'm testing out a new antenna. How's it sounding? They're going to come back and say, hey, you're sounding great. Or, you know, you're a little bit not quite there yet. You might try this. And they'll give you that information. So never be afraid to ask, you know, out on the airways, how am I sounding?
Keep in mind that everybody started right where you are. We all were right there. All of us had to have a clue how to tune the radio, how to talk in the mic, what the correct terminology is. None of us. So always keep that in mind. The guy that thinks he's better than you are, he wasn't. We're all the same.
Yeah. And that's one of the things I really like about the ham community is the camaraderie and the help. I mean, they're always willing to help. Okay. Another term that you'll hear is PEP, peak envelope power. Any idea what peak envelope power means?
First I need to know what the envelope means.
Okay.
Did we already learn that? Because we did it. One in one ear and out the other.
No, I don't. Where did I put it? It's right in front of me. That kind of would be an envelope, right? Right in here, this area, the signal.
So what the signal looks like?
Yeah, it's kind of what the signal looks like. And what you're doing is you're putting power to this signal to send it out, right? And so peak envelope power is the measure of an AM or a single sideband's power. It's a measure of the power that you're putting out there. And PEP is the transmitter output power when speech is into the microphone is the loudest. Okay, so what's it sound like when I'm really loud? And you don't want to be overbearing, right? So what happens if you're talking way too loud into the microphone and you're just really pushing that power out? What should you do?
That's not your gain, is it?
Or,
What you do is you either soften up or you pull your microphone away. And then you'll be able to be heard. It's kind of a science, you know, how close do you want to hold this? And you know, some folks get it real easy and real quick. Others, it takes a little bit of time. And this is where, you know, your other ham community, just ask them and they'll help you. How am I sounding?
my wife will get out our radio, I've got a called a desk mic, that's a hand mic, and we've got a desk mic set to it, and you speak into it. She speaks quietly, so she gotta speak louder. So she backs off the mic and yells. Get closer to the mic and talk quiet.
Did it get distorted? Too loud?
Yes, it can get distorted, definitely. So,
Learning process.
so it is a learning process, and but that's what it means is when you're talking about peak envelope power. Another term that you're going to hear quite often is a dummy load, and so you know when I'm playing with this radio and I want to make adjustments, I want to make adjustments to the mic gain, and I want to test, and there's some meters on here that'll show me how it's doing, right? You can put what they call a dummy load on the back where your antennas hook. And it's basically, Randy's going to go grab a dummy load, I think.
Yeah.
And we'll show you what that is. But it's a heavy-duty resistor that can absorb and dissipate that output power from a transmitter. Okay, so it takes that power that you're transmitting right into a dummy load. So you're not transmitting it out there because you don't want to transmit that out there onto the airways. You know, you're just trying to adjust your radio, and you want to make it the best you can. So you put it on a dummy load. Now, if I were to transmit on this thing without a dummy load and without an antenna, you don't ever want to do that. Okay, because you're going to damage your radio.
No place for the power to go.
There's no place for the power to go, and guess where that heat's going to be absorbed? It's going to be absorbed right into that radio. But this is a dummy load.
It's a high power one.
Wow.
This has got oil in it.
Yeah, so it's filled with oil, okay, and you hook your coax to it,
Right up to the top here.
and you can transmit to your heart's desire as you tweak your radio, make the
But
adjustments.
how do you know what it's doing if it's, I mean,
Does
you're
it-
not
This
hearing
is
yourself,
50
right?
ohm. This is the match. So a perfect antenna is 50 ohm. And this is a 50 ohm. So this is the same thing as seeing an antenna without putting the airwaves out.
But how do you know,
What it sounds
how do
like.
you adjust it if you don't know what you're sounding like?
You can adjust it on the meter.
There
Oh,
are meters
okay.
on here that you can adjust to,
I see.
and you can get them right where you want,
Like in a
and then
certain range on
yeah.
there, okay.
This is a commercial one.
That is a commercial?
Yes.
It's like a honey bucket to me.
Yeah, kind of. This is a heat kit. So this was built by
Heat kit.
somebody.
That's an old one.
Yeah. All right. And this is just some examples of some of the buttons you'll see for, you know, if you have RF gain, this button down here is AF gain, and this one here is RF gain. And you can adjust that, and where am I at? So your AF gain basically on your radio is going to control your volume, and your RF gain is going to, where am I at? On your power out, on what you're sending out. Okay. So that's just an example of some of the knobs you'll see on some of the different radios. Okay, Now, this is a key one. This one's going to be Rick.
Just a quick question on the RF gain. Does that bring down noise floor a little bit? You increase it?
No, it shouldn't affect the noise floor at all.
Okay.
Noise
Yeah.
floor is received.
It's constant.
Yeah.
Yep. Okay, so as you look at your band plan, okay, you got edges of this band plan. Now, when I'm on the radio, if I have my radio and I'm going right to the very edge of that band plan, I'm legal. I'm legal for that frequency. But what's going to happen if I broadcast? It's going to drift. You know, it's going to be this side or this side of that frequency. So you never want to broadcast right on the edge of the band because you're going to be broadcasting outside of your legal capability. Okay? So you always want to broadcast, they usually say 3 megahertz inside of the band plan. So if you're broadcasting towards the bottom end of the band plan, you want to be on a frequency at least 3 megahertz above the bottom. If you're at the top, you want to be at least 3 below the top.
Question, you're saying megahertz, but there it says 10 kilohertz. I mean, so what?
We live dangerously.
Yeah.
More is better.
More is better. That's
The quick and dirty, you want to make sure that you're really not getting too close.
Right, right, okay, it's just megahertz is a lot bigger.
megahertz is bigger, and I believe, and I don't remember whether it was general or extra, talks about that more.
Okay?
Past it.
But anyway, you want to make sure that you're far enough away from the edge of that band that your radio is not broadcasting outside of your band privileges. Somebody will tell you.
Somebody will tell you.
So you just don't want to do that. So that's just a word for the wise, and yeah. So as we talk about, we got just a few more things to cover here. As we talk about spurious signals, if we have excessive modulation, too much power, it's going to result in distortion, as you mentioned, Howard. We're going to have some distortion, and the speech, and we're going to have unwanted spurious transmissions outside of the adjacent frequencies. Occasionally, what you'll hear, somebody's just coming across the bands, and they're just really punching it out, and they're punching it out across a wide range, and it makes it a hassle for everybody. It's no fun. You know, if somebody's out there and they're overmodulating, they're splattering all over the bands, you can't get a clear band, or if you're talking to somebody and all of a sudden somebody's on another band and they come across you, it's like, dude, turn it down. And so you'll see that, but you don't want to be the one that's splattering out there.
Especially if you give your call sign.
Yeah.
The cams are legal to use up to 1,500 watts of power. And if you're not completely adjusted properly, it makes a mess. So the guy's talking on this frequency, but you can hear him halfway down the band. It's got so much power. And the transceivers, the receiver, can't filter it out. You know, you have built-in filters, but you just can't get rid of it. It's so loud. Contest weekends, you'll hear that often on the high-power stations. So it's legal. It's legal. It's just, it's not nice.
They're using the whole bandwidth then.
It takes a lot of it.
Yeah, it does take a lot of it. So you don't want to be that person.
That's with more power than you need.
More, yep. If you have more power than what you need, yep. Yeah.
When you have a CB, and I just have a short question.
Mhm.
And you're doing something wrong, somebody may say, turn your squelch down. What does squelch mean? Do you know?
Yes.
Is that splatter?
No,
No.
squelch, it starts to take away the bottom part of the signal. So squelch is all receive. So if you turn your squelch down, you can take the noise out. But it doesn't do anything for the transmitter signal. So if they say turn your squelch down, that means that.
It just means a clearer signal.
It's on what you're.
On what you're hearing.
If you're listening to a lot of noise, you can turn your squelch up and the noise goes away and you just hear the voice. If you open your squelch wide open, you get all that noise that's always on the bass.
Yeah.
So that's the only thing it does is eliminate.
Noise. Takes away noise, static.
Yeah, it takes, and then you can get the strong signals that are coming in. If you've got a weak signal that's coming in and you turn your squelch up, it'll take that weak signal out too. So it's something that you kind of got to play with to get it just in the right spot.
It's all receive.
But good question. Good question. Okay.
Did you say CB?
All right, so receiver functions. The receiver has a difficult task. It needs to pick out just the one signal that you want out of all the other signals. So this radio, it's going to hear all these signals and it wants to pick out just that one. The one on one frequency, you know. And so you got the AF gain button, which is our volume. There's also a clear and a shift. And you can vary the receiver frequency without changing the transmit frequency. So it just kind of helps you to clean things up and clarify, you know, that's what CLAR stands for. And then there's ATT, which adds attenuation to reduce the strength of very strong signals that are received. It just helps to clean things up as you're trying to listen to those signals. So some of the common radio controls, that's just kind of a picture of what we talked about over here. You know, the clarifier, the shift. That TT on the left, that is ATT, attenuator. And then your AF is your volume. Okay.
Why doesn't it just say volume?
Too easy, wouldn't it?
It'd hurt my brain less if it would just say over there.
Just to call it VO.
Well, it could be like noise reducer. I don't know.
Well, they do have some of those in there too. Some of the other buttons will take you to those menus. But yeah, some of the terminology is just kind of different language that comes natural. After you play with the buttons for a while, you go, oh yeah, that's my volume. That's my volume.
Sometimes in the dark, but you can't read like on or off.
So you got to know where the switch is, right? Okay, so sensitivity. You know, that's one thing about radios. You know, how sensitive is it? Sensitivity really determines the receiver's ability to detect signals, and it's specified as a minimum detectable signal. So if you got the lower the minimum detectable signal is, the more sensitive your receiver is. So you want to be able to get those sensitivity so you can detect some of those weak signals. You had a guy that was able to detect a weak signal down in Mississippi from up here, and
Yeah, 3-3.
gave him a 3.3. Now he's going, what's a 3.3? That doesn't mean anything to me. But when you're talking about signals and you give signal reports to people, you're basically saying, how well are you coming in? I can hear you, and I can understand you. So the first number is, how well can I hear you? Second number is the signal strength. How well are you actually coming in? And so if you got a real good signal and you're really getting heard well, it's a 5.
5 is one.
And if you got a good solid signal coming at you, it's a 9. You can hear them, you can understand them. A 5.9 is basically right on where you want to be. But you can be at a 5.4, 3.3. I had a 3.3 when I was over in Theodore Roosevelt National Park. I had a 3.3. Made contact with the guy. He was coming in booming at a 5.9. He was hearing me at a 3.3. But hey, made the contact, right?
pretty stinky.
The difficult part with a 3.3, for example, is that the guy that gave you the 3.3, he's got a really good sensitive receiver. He can hear you, and he doesn't have a lot of noise. So I got his 3.3 when I was out in the park as well. And this guy was coming in 5.7. I can hear him perfectly, but he get a 7 on the meter. So you give him back the 5.7, you get a 3.3, that is illegal contact. It doesn't matter the signal strength as long as
It's readable. All right. Then another piece of things to consider with your radio is the selectivity. And the selectivity is the ability of the receiver to discriminate between signals. So if you've got a good solid signal coming in, you got a weak signal, can it disseminate between those two? Can it determine what they are? Higher selectivity equals the receiver operating properly in the presence of strong signals on nearby frequencies. That's what you're talking. Somebody's splattering, right? And they're coming across onto the frequency that you want to use. Can your radio pick out someone on the frequency that you want to use? Okay, that's what the selectivity is all about.
a lot of the new radios will give you different filters. So just push a button and it narrows it. Push it again and it narrows it more yet. So you can filter out most of the spurious signals.
Yeah.
The old radios didn't have that. The new ones do.
So we've come a long ways over the years from the good old tube types, yeah. Okay, we'll just go quickly into some of the digital communication. There are different combinations of protocols, codes, and modulations, such as single sideband and or FM, used to create digital signals, the digital modes. Each mode has its own advantages and disadvantages for speed, error rate, and how it's used. And the FCC rules also place different limits on how fast digital data may be transmitted on the different bands. This means that different modes are more popular on different bands. And I don't know why this is in here. We'll jump back to it if we need to. So popular digital modes on HF were single sideband modulation and the ionosphere, or the skip. You know, we're going a long way, right? We talked about the skip. Hit the ionosphere and we bounce back down. So where that's the norm, popular digital modes include RTTY, keyboard to keyboard, using such modes as PSK31, that's a digital mode. Weak signal modes, which are very popular, are FT8 and Whisper. And Pactor or Winmore modes for WinLink system messaging. So I've mainly on digital stuff that I've used is the FT8, and that can be a lot of fun. Let me show you. You hook your computer up to an interface with your radio, and then basically your computer is controlling your radio. And you'll see the signals coming in. You set it up to a certain frequency. You get your radio. You have to do some settings in your radio and some settings in your computer so that they're talking to each other. And then it'll start receiving signals in. And you can pick them up and you try to make contacts with them. And you know, it's kind of fun. They'll send you certain information. Your computer will send back the same certain information.
So is that information on your monitor or on computer speakers?
It's on your monitor.
Okay.
Yep, so you're actually watching it as it happens. Lee does it a lot of times. He spends a lot of... He's got 12,000 contacts on FT8. So he's making a lot of contact. And how far are your contacts, Lee?
Oh, everywhere. The farthest, probably Asiatic Russia. I saw one where the map map of the world is basically a square, so it's not a globe, but the signal went straight up, over to the right, and straight down, which essentially means it was directly over the pole.
So.
If you're shy and you don't like to pick up that microphone, FT is the way to go. All you need is a finger. click, and you do the content.
It's nice for watching TV too, because you click and watch TV.
And the computer tells you when you have a call you want to get, or a state, or a country, so technology is just unbelievable with amateur radio.
Yeah, one of the things that I have a map that comes up, and it'll show me where my signal is getting to, where they're hearing my signal as I transmit. Where's my signal being heard? And a lot of times I can see, oh, hey, I'm being heard over in Spain, and you know, they're hearing me, and you can see how far out.
How does your equipment know that?
So they have it set up. They're in the same program, and they'll bounce a signal back,
Oh,
and so you can. They tell you where you're being heard.
so it's just talking, your computer, your radios are talking back and forth and it's coming through your computer and it's.
In FT8, it's calculated by the grid square. The Maidenhead grid square ours happens to be Echo November 25, and it's a small square of part of Minnesota. There's grid squares all over the world, of course. So it's calculated by the grid square. If I send my signal over to somebody and they send it back, the computer knows what grid square it is and tells me where it is.
Yeah, so it gets to be a lot of fun, and so that's some of the digital stuff that we play with.
So does the computer have to be on the internet?
Yes.
Yes,
It does,
Yep.
okay.
To do that.
to do that. Yep.
Okay.
All
Other
right.
modes, no, but that particular mode,
So you
yes.
can still use your computer to talk, for digital transmission or receiving without actually being connected to the internet?
Yes,
In some modes, yes.
Yeah, like-
FD8 does need to be connected.
but like WinLink, that's an opportunity to send email via your radio. You do not have to be connected to the internet to do that. Your radio is making that transmission of that email for you. Okay, power supplies. How do you power this radio? And why is it important? Why is a solid power source important? Well, we need clean power, right? We don't want to be running dirty power into a radio because it can damage your radio. Solid power, you get noise free. You get a noise free and you get better reception. So you're transmitting with less noise, you're getting better reception. There's multiple ways that you can power your radio. Tonight, I'm just coming off of a battery, okay? And but household current, at home when I'm operating, I have a power supply. I plug into the wall, then I plug my radio into the power supply. So what it does is it takes it from AC and converts it down to DC because I have to power the radio with direct current.
Because it's a mobile? Or what? Why does it have to be direct current? Why can't you just plug it in?
Why can't you just plug it into the wall?
Most radios are set up as 12 volt DC.
Whoa,
And they like to run about 13.6, 13.7. So what they like.
What do you mean by clean power, dirty power?
So if your power is not coming through at a straight constant amount, you could.
When you plug it into the wall, you have no control over that, do you?
The power supply itself regulates the power.
It'll filter out any of the bad stuff, the garbage.
A dirty power supply, you'll hear noise on the transmitter signal. You hear static. It's not real clean. A nice clean power supply doesn't affect your transmitted power. So it's clean, probably a high quality would be another way to say it.
Yep, high quality power.
Buy a good power supply as opposed to a real cheap one that might not filter all the noise out.
Well,
Go ahead.
I think, I don't know if this is what he was saying, but yeah, I guess we should want to know an example of a dirty power supply, not how you get dirty power.
So if you got a dirty power supply, let's say you buy a cheap one, a cheap power. So
What is a cheap power supply you would buy?
Cheap battery?
No.
Yeah, what's an example of
So I go online and I see a power supply for $10. It's going to ship from China. I don't know what it's like.
Will it be a battery of some sort?
No, what it does is that the power supply will, you plug it into the wall and it converts it to 12 volt. So that
So
you,
it's like a transformer?
it's like a transformer. Yep. So it transforms your power from alternating current down to direct current. Now, if you've got a bad power supply, it can give you some real problems. If it's not doing that transformation from AC to DC cleanly, you're going to get noise when you transmit. And you could also get noise when you're listening. And
You mean, so when, if we were going through a brownout, electric grid,
that could give you some problems, yeah.
that would be dirty,
That would be dirty, yeah.
because it's not up to the full.
It's not up to the full amount. So on a
Can you tell
power,
us which one to buy so we don't buy crummy ones?
Yeah,
yes, we can do that.
Don't your radios have a power supply built in?
some of them, but most of them don't.
Most of them do not.
To get a built-in power supply and radio, you're getting up towards the high-end radios, they're thousands of dollars per radio.
Oh, does yours have a power supply built in?
I don't think mine was thousands of dollars radio.
Is that battery specifically made for your radio then? Or is this a common,
This is a common battery, okay?
a lawnmower battery? Or is it something designed
Did-
for,
As long as it's 12 volts.
As long as it's 12 volt, you can use different kinds of batteries.
long as a what?
12 volt.
12 volt.
battery.
Yep. This one happens to be a LiPro lithium phosphate. So this is a lithium phosphate battery, and they're making new and better batteries all the time.
But a regular power supply that you're talking about is something that you plug into the wall? and
Something
then
I
you
plug
your
into the wall
radio
and
into
plug the radio
power
into the
supply.
power supply. Yep.
And what would a good one cost, or a decent one cost?
$200.
Yeah. Yeah, I think I paid 125 for mine, something like
Can
that.
you just get it on Amazon or?
Yes, you can.
You're better off looking at a radio store. so
Like
to speak,
DX
a ham
Engineering
radio
or something like
outlet,
that?
Yeah,
DX
Dick-
Engineering, R&L, things like that.
Yeah, I think I bought mine from R&L because a lot of times when I'm buying stuff for the radio, I want to make sure that it's designed, to work with the radio. And at those locations, Ham Radio Outlet, R&L,
Gigaparts.
Gigaparts, DX Engineering, that's what they're in the business for. And they've tested it, right? They've tested those, so
That doesn't mean that you can't go to one of those places, find a power supply that you like, then go to Amazon and find that exact model and find it cheaper.
There you go.
yeah. So it's, the comparison shopping type thing. But
I'd rather give DX Engineering my business than Amazon also.
Amazon smile.
yes, Penny.
Well, so can you, would like regular batteries like AA's, can they be used?
I wouldn't, but you could build.
As long as you get 12 volts, 12 volts on.
Okay, I'm not sure how many volts are in a AA battery?
Like what 1.5 or something, and
Oh, okay.
they're not.
So you need a lot more than.
Yeah, they're not going to last. I mean, this one here is a 16 amp hour battery,
Oh, okay.
and it will last me a good 4 to 5 hours of solid working without recharging it.
But not at 100 watts.
Yeah, these
Not
are-
at 100 watts.
These things will draw 23 amps. or
Is that
something.
a lead-based battery?
No, this is a lithium phosphate. Lithium phosphate.
Do you use a power supply from a computer?
Do I use a power supply to run a computer?
From a computer.
From a computer.
As long as it'll take 23 amp.
23, okay.
23 amp.
Yeah, I know.
These draw about 23 at 100 watts. So if you're gonna get a power supply, I would get a 30, 35 amp power supply.
Okay.
That gives you a little bit of,
It gives you some cushion that you're not.
You can charge that battery.
Yes.
I mean, you run it down, but
Yep.
you can charge it
Yep.
over and over and over again.
Yeah, it's got a life cycle, but it's got like 2,000.
until the battery itself wears out. You just recharge it and use it. Lithium goes longer than a normal battery. Not saying normal, a lead acid battery. Like a car battery, lead acid,
Yes,
They don't last as long. You can't recharge them as many times. Lithium, you can charge quite a few times more.
Lithium, you can drain to nothingness and charge it back up.
Yeah.
Lead acid, you get down to around 7, you may never bring the battery back.
Yeah.
Most of us are also carrying solar panels,
Yep.
which
Yep.
will extend the life of the battery. It isn't gonna keep it charged probably, but it will extend the life of use of the battery to, Jeff said 4 hours, for example. Maybe it'll get to 6, type of thing.
Yeah. And, you know, if I need to, I hook this up to my solar panel and I just leave it out there and it'll ultimately recharge it all the way up to full strength.
So a big base radio, the bigger ones, can you hook them up to a battery like that?
Mm-hmm.
Yes.
Sure.
Okay, because mine just has a plug-in, you know, AC plug-in, so I would have to buy a,
That,
That is,
if you got your radio plugged into the wall, that's got a built-in power supply in it.
oh, it does?
Yeah,
It
so
would.
as long as you plug it in the wall, you're good to go.
Yeah, it has a plug-in for the
It's got a
wall.
built-in power supply.
Oh, okay.
Yeah.
So I wouldn't even be able to use a battery on mine then,
I
like say
think
grid down?
there's still a 12-volt plug-in on it. I think you could run a battery
There
if
would
you
be?
wanted to, yeah.
Oh, okay.
Yeah, there should be on the back of
the
it.
little box there is the converter. That?
No, this?
Oh.
No, this just a box.
I thought there was a converter.
Nope.
That's the range.
Nope, for this one, since this is 12 volts going directly into my radio, that's all it needs to be. Now, if I was wanting to run off,
AC,
if I was running AC, then I would have to come through my power supply to my radio.
okay, but you don't have one of the
I didn't bring my power supply tonight.
converter.
Yeah, I did not bring that with me tonight.
Inverter.
Inverter, yeah.
When you guys leave tonight, Lee will show you the power supply we use out here. And this power supply, I think it's a 50
amps.
amp. That powers the HF radio and 1, 2, 3, 4 VHF, UHF radios. So, lot of
And
power.
the signaling.
All the signals,
So it powers a lot of good stuff. So these are the ways that we can power these radios. And you just have to be careful, making sure that you've got the right voltage coming into your radio. As Rick has found out the hard way a couple of times.
All you hear is it,
And then that's it.
and you smell it.
All right, and that is what I have for this evening. Any questions?
Think we interrupted you enough times by asking.
No. The only question that's not good is the one that's not asked.